So this is about asymptotic comparison of sequences. Okay, so sometimes in order to solve indeterminations, just like the ones we saw in the video before, it's useful to compare how different sequences behave when n gets very large. Okay, so when n is getting closer and closer to infinity, then for instance a sub n and b sub n may be very close. Okay, so for instance, we saw in the last example that the limit when n goes to infinity of 1 plus 1 over 2 plus 1 over 3 plus blah 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 plus 1 over n divided by the logarithm of n is 1. Okay? Check last video for this example. Right? So this means that when n is very large, this sequence and this sequence are very similar to each other, right? So this is the rigorous definition of that. Okay, so let a sub n and b sub n be two sequences which either both diverge or both converge to 0. Okay, so we say that a sub n and b sub n are equivalent, and we denote it like this with this curly tilde. If the limit of a sub n divided by b sub n is equal to 1. Okay, so that means that if the limit of a sub n is when n goes to infinity is infinity, then b sub n is also infinity, but the division between both is 1. And a sub n is negligible compared to b sub n, and we denote it like this with this symbol if the limit of a sub n divided by b sub n is 0. Okay, so that means that b sub n is either growing to infinity much faster than what a sub n is doing, or if it's going to 0, this is going to 0 much faster than b sub n, right? So in this case, this means that both sequences are growing to infinity at the same rate, right? We know that the logarithm of n, when n goes to infinity, which means, and this is an interesting proof of this result, that this sum, 1 plus 1 over 2 plus 1 over 3 plus 1 over n, which is called the harmonic sum, okay, goes to infinity when n goes to infinity. Okay, so this sum, as you can think, this is the sum of an infinite number of terms that are smaller and smaller and smaller. It still go up to infinity when n gets large, right? And we will see this in next unit, which is about series, which is about infinite sums. Okay, so we'll see that in the next videos. Okay, so this is an example of equivalent sequences. For instance, a negligible sequence is, for instance, n and n squared. Well, then a sub n is negligible when compared to b sub n, right? Because the limit when n goes to infinity of n divided by n squared is 1 over n, and this limit is 0, right? Okay.